All right, this seems fun. What's happening right now? Honestly, this job shouldn't be so hard. Okay, let's go ahead and make ourselves a key for the quiz review because that way you don't have any excuses for not knowing what you're doing. You can just watch this video over and over again. So, first of all, it says determine whether the function represents growth or decay. So keep in mind exponential function looks like this, and the growth factor is this thing that's raised to the power. It'll be growth if b is greater than 1. It will be decay if b is less than 1. Numbers are getting bigger in growth, smaller in decay. So all I have to look for is the thing that's raised to the power. So here the b is 1/2, less than 1. This is going to be decay. Careful with this. This is a fraction, which is really deceptive, but 5/4 has a bigger number on the top. So it actually is greater than 1. If you're terrible at fractions, just do 5 divided by 4 on your calculator. It's going to come out as 1.25. So that's bigger than 1, so that's going to be growth. And this last one has the number that's raised to the power, therefore the growth factor is 0.25, and that is less than 1. And so that makes this a decay as well. All right. So domain on these is really easy because every exponential function has all real numbers as the domain. It goes forever from left to right. You can write it however you want, negative infinity to infinity. You can write it out as all real numbers. You can write whatever you want. That means all real numbers. You can't literally write whatever you want. Okay, now some important features. What do I need to do? First thing, these have asymptotes. So I'm going to go ahead and look to see what's at the end. Since this doesn't have anything added at the end, then it doesn't move, and my horizontal asymptote is going to be at 0. So that means I draw that line in right here. And that also tells me immediately that my range is y is greater than that, because that's like the floor of our graph. I'm going to erase this so I have a spot here. I'm going to go ahead and put my table. This one has a 2 here, which is bigger than 1, so I expect this to be growth. So it should go up from left to right, but never touch this asymptote. So I'm going to go ahead and plug in some numbers. I'm looking at the answer key online, and I never even drew the graph. So let's do that now. So this gets a little tedious. I keep saying that, but that's because it's true. You're going to put in some numbers and then see. I just pick those same numbers. As you guys know from the worksheet, sometimes they're great, sometimes they're terrible. All right, so I'm just doing a little calculation here. Here I got a 1, 2, 4, 8, 16. All right, well, those aren't all going to fit on there. So this is here. -1 goes up to 2. 0 goes up to 4. 1 is already off the table, and certainly 16 is way up there. So I draw this in. I have to kind of be careful about this end because I want to make sure that it shows like it's going close to the graph but not actually touching it. I should say the asymptote. Here, same thinking, but this one has a +2 at the end, which is going to move the graph up 2. This is going to move it left 1, which is not really my business to graph. I'll just use points to help me out. And then this is a value less than 1. So that is going to be decay. So then I'm thinking as I go through this, this is going to be decay. Now let's go back to this business about moving up 2. If you move up 2, that moves your horizontal asymptote up 2. The floor just went up to 2. And if you have a horizontal asymptote at 2, that's going to mean your range is tied to that value and your graph will stay above that. And then I'm going to see, sometimes the numbers that we've been using are not awesome and they get really, really small or really, really big. So let me see how this one plays out. I'm going to type it in just like it appears, like 1/3, 1 divided by 3, and then raise it to the power of x plus 1. Remember to put that in parentheses if you have an older calculator like me that doesn't actually display it up high like a power. If it's just sitting there next to the other ones, then you're going to need parentheses so it knows what's going on. Okay, so I'm going to look at my table. Actually, I'm not because I accidentally graphed it. Ooh, that's what my graph's going to look like. Okay, So when I plugged in a -2, I got a 5. When I plugged in -1, I got 3, 2.3, 2.1, 2.03. I can't actually see, it's really dark. It's like 2.04. Okay, so that makes sense because that -2, and you still start from here, you start from the origin. So I go to -2, up 1, 2, 3, 4, 5. From -1, I go up 1, 2, 3. At 0, I go up 2.3, and then it just keeps getting closer and closer, which makes sense because it's exponential decay. So it's come skirting in here next to the asymptote and comes down from left to right. Alrighty, last one. This is going to move down 4, left 1, and it's raised, the thing raised to the power is a 3. So this is going to be actual growth. Down 4 is going to mean that my asymptote and everything moves down 4. So if this is my horizontal asymptote, my range will be above -4. All right, then I'm going to make myself another table and see how the numbers go. And as the problem gets more complicated, it's trickier to plug it all in. And if your tactic has been to just copy what I have, that's a fabulous plan until you don't know how to type stuff in during the test and you ask me and I won't tell you because we've been practicing it. So make sure that you are at some point practicing it. This is giving me -3.7-ish. I'm letting my calculator plug them in, and so I know I'm going fast. If you need to, stop the video and make sure you know how to get those numbers. So at -2, I'm down 1, 2, 3.7. At -1, I'm down 1, 2, 3. 0, I'm at -1. 1, I'm at +5. At 2, I'm at 23. Way super off the page. So I'm just going to draw this little part in and then scoot it up there. Awesome. Okay, so that was all day 1. Like all of this stuff is 7.1. And now this stuff's going to start being some 7.2. So what are my formulas? Okay, the value of a car depreciates. That's going to be going down 20%. If you don't feel like you know how to get the decimal scooted over, just take the 20, divide it by 100, and it's going to give you 0.2 as an R value. That's your actual rate. Depreciating means you're going to be using 1 minus R. A particular model of car is $23,000. That's going to be the starting amount. Write an exponential model. That's just the equation. So this is not compounded because it never says compounded. So keep in mind that our formula is A1 and then either plus or minus R, depending on if you have growth or decay, to the T. So for us, we're going to have Y equals, our initial value was 23,000. And here we have a 20% depreciation. So we'll have 1 minus 0.2 in here. You can leave it as that, or you can write it as 0.8. I don't really care. I think I put both on the answer key. And then, oh, I had to take a little break. My little dog needs to go outside. You want to go outside, buddy? He does. He doesn't. Okay. And then that's going to be to the T power. Because the model doesn't give me a Y and it doesn't give me a T. Those are going to be for me to figure out later. Like right now, where it says 3.5 years, estimate the value. So that's my T. So I just take my equation, my model, my formula, whatever you want to call it, and I go ahead and I put in my 3.5 years as a power. Keeping in mind, this should get smaller. It's depreciating. So I'm typing that whole thing into my calculator. And again, make sure that you know how to do that and that you can get that 3.5 in there. And I'm getting a value of $10,532.77. Since the school opened with 300 students, so that's the initial value, it's increasing. So we're going to have 1 plus R. at a rate of 2%. So again, if you don't feel comfortable, just do 2% divided by 100, and it will tell you that that's 0.02. Okay, so write my model. So y equals, now my first value is 300. That's my starting amount of students. Since it's increasing, I'll be adding my r value of 0.02 over here to the 1, which is representing what I already had, and then to the t power. You can write it just like that, or you can write it like 300 and then go ahead and add them together. And this is growth, so it makes sense to me that the thing raised to the power, the growth factor, is greater than 1. And then whenever I have a model, I have a y and a t in there as letters. Then it says estimate the population after 10 years. So that's the t they want me to plug in. So I give that a little whirl. And I put in a time of 10 years. And I'm getting, no, this is students, so you can't really have a decimal. So I'm getting like 365.7-ish, and that's probably what I have on there. But really, it probably makes the most sense to go ahead and round it off to the whole number, because 365.7 students doesn't make a lot of sense. I'm not going to be picky about that, because that's kind of not what we're focusing on. Okay, this next one has a part of it that I want to make sure you know how to do, because we had one on the worksheet and it was kind of confusing, and I want to make sure you know. So it's giving us a period of time, which I'm not going to worry about from right now. The only thing I am going to think about is that 1997 is the start. So any other t is going to equal years after whatever that start date was. So in this case, 1997. So the number in millions of black and white TVs sold in the US can be modeled by this. Modeled by simply means this is the equation, and this equation should not be particularly shocking to you. This is my y equals a. This came from 1 plus or minus r to the t. It says in here, identify the decay factor. Plus, if you look at this, it's less than 1, which means this is decay. So what I know then is that up here, this is going to be the formula that's 1 minus r. So somehow 1 minus r became that 0.85. So this is the decay factor, the growth factor. It's asking you for the b value, the thing raised to the power. So that's the 0.85. What about the initial value? It doesn't ask you that, but the initial value, your starting number is 26.8, and that's in millions because it says so up in the words right here. But what about percent decrease? So that's kind of confusing. What I like to think about is like that 85 came from 1 minus whatever the percent rate was. And so then I'm going to go ahead and take this away to kind of figure out what that would be, and think, all right, I got 85. I did 1 minus r to get that. So when I do that, I get negative r equals negative 0.15. I can cancel out the negatives because there's one on both sides. And I'm getting an r value of 0.15. So what that means is I got my 85 by taking 1 minus 0.15. Okay, but then as a percent, what would that be? Since I usually move it to the left and I'm working backwards, I got to move it over to the right. So I end up with a 15% decrease, because this right here really represents 85%. So I think that part's confusing. I'll probably make that kind of, if that's on there, I'll make that part a little extra credit. And then it says, estimate the number of black and white TVs sold in 99. So the only thing a little bit tricky about that is for this, you have to think, what's T going to be? And it's going to be 1999, and find out how far is that from our start date way back here of 1997. So that's 2 years later. So to do my estimate, I'm going to just use this formula, and I'm going to be plugging in a 2 for T. So I'm doing 26.8, and then in parentheses, 0.85, raised to the 2, because it's 2 years later. And I'm getting 19.36, and that is in millions. Okay, so that's the end of 7.2, and now we're into 7.3 where we learned about E. So when it says leave E in your answer, it means leave E in your answer, and just treat it like when we were doing these as powers of X. If we had that, we would go ahead and do it a couple different ways, but what I usually did was move anything with a negative power down. So I would have had this over this, and then I would have said, okay, there's 3 on top, 7 on the bottom. How many extras and where are they? And they would have been down here. That's exactly what we're doing, except our base is E instead of X. So here, there's a couple ways to do it, but one is to move that down since it's negative. Now I have that. And this is like having 3 of them on the top and 1, 2, 3, 4, 5, 6, 7 of them on the bottom, which is why you end up with 1 over E to the 4th power. And there's another way to think of it. You could also be like, wait, when they're neighbors like that, the powers add. So 3 plus -7 will put me at E to the -4, but you can't have negative powers in your answer. And so you have to move it into the bottom and get that same answer as I had from the other method. I don't want you to do it both ways. I just want you to have a way. 3 over 9 reduces like it always has since forever ago. So that's going to be 1 over 3. And then if you look at these, you think how many there are. There's a difference of 5, and they'll be wherever the leftovers are, which is going to be on the top. You don't really have to write the 1. It's fine if you do. It's fine if you don't. Okay, we studied these two. Cube root, this is a gatekeeper. You need a cube to take that out. So our perfect cubes, and again, we used to have a chart for that, and I'll give you another chart, but we're looking at like 3 of something. So if you think about 8 as 2 times 2 times 2, 8 is a perfect cube because it's 2 times 2 times 2. So the 2 gets out because it takes 3 to get out of here, and there's 3 of them. And then the next thing is this. Oops. And so that is going to be the same as, I guess what I would probably do to make this easiest is I would say, I have 9x, and I'm trying to divide 9x into groups of 3 because of that index. So 9x divided by 3 would give that a power of 3x, because if you did 9x over 3, you'd end up with 3x. So I don't end up having anything left over because it divides out equally. So then this is my answer. So don't freak out again. If you have x to the second times x to the third, you add the powers. Same thing here. If you have e to the x and 5e, you're multiplying these. So you would multiply the numbers together and still just get a 5 out front. But you have e to the x times e to the x plus 3. So because they have the same base, you can add their powers. And then you've been in algebra long enough to know that an x plus an x makes 2x plus 3. All right. Now, this is telling you what to do. So sometimes on the test, you guys come up and ask me about stuff. Think about it. Just look and see what it's telling you to do. It's literally asking you to type it into your calculator. And it's also telling you 3 decimal places. So you're going to go to your calculator. I would go to the second function. And then you're going to have a button that probably says ln. And e is most likely the second function. And it'll have it raised to a power. They're asking for it to the third power. Try it on your calculator. See if you get this. Here you're typing it in exactly like that. 2 times e raised to the negative 0.3 power. And you should get this. And I'm writing my answers to 3 decimals because that's what they said to do. Now, obviously, this next one is formatted like compound interest. And so this would be like your principal, your rate, your N, your T. So it's just having you practice the math of putting that in your calculator. So in the end, that 4,000 turns into 5,670. And then this did say 3 decimals, so I'm writing them all out. And again, put them in your calculator. Make sure you know how to get that. Don't just copy the fact that I got that. Pay attention to this guy because this is our little PERT equation, which we use with, this is the principal, the rate, and the time, but E is telling us that it was continuous. So this is just helping us practice for those upcoming word problems. If you type that into your calculator accurately, you will get this. So check those out. Make sure that you don't just believe me, but that you actually know how to do them. All right. Now we're going to get into our interest problems. It says you deposit 500. So this is actually kind of back to 7.2 with the exception of this part. So you deposit 500. So for all of these problems, that's going to be the P in our A equals P problem. Then we have 1 always plus R over N to the NT power. And that is if you can count the number of compoundings. So how many times does it say that it's getting compounded? And that's per year. So if they say it's compounded monthly, that would be 12 times a year. Quarterly, and they actually have that written for you here. They're saying, hey, quarterly would be 4 times a year. Annually is 1 time a year. Monthly is 12 times a year. Continuously means all the time, and that gets its own formula that utilizes E. And then you raise it to the R times T power. Maybe you need parentheses there and there, depending on the age of your calculator. Okay, 3.4% interest rate when I divide that by 100 is going to put me at an R of 0.034. That's going to be what I actually use in my formula. Leave it in for 10 years, so T is 10. How much would you have in the account if it was compounded annually? So this is just going to be really repetitive. I'm going to have my 500 principal, 1 plus my 0.034 rate. Annually is once a year, and then this is going to be once a year times the 10 years that they said they wanted it in there. So if you run that through your calculator, keeping in mind that it should be increasing your money's value, you end up there. And then this is a complete repeat performance. The rate stays the same, the principal stayed the same, but now it's compounded quarterly, so that's 4 times a year. And then you have to say, well, that's 4 times a year times 10 years. So it's actually going to be compounded 40 times. That kicked out this value. Again, try it on your calculator. Monthly, I still put in 500. This is a 1. I still have the same interest rate, but now it's 12 times a year. And that's 12 times a year for 10 years. So I put that into my calculator, and I got this. And then continuously is telling you that you have to use this formula. That's the only time you use it, and it's the only formula that works for continuously, because continuously means an infinite number of times a year, and you can't plug infinity into a formula. But you still have 500 as your principal. E is now a part of your equation, just like pi is a part of a bunch of a circle equations. And then you're raising it to the R, which is 0.034, times T, which is 10 years. So when I did that, I still got 702, but it went up a little bit to 47 cents. You don't need to memorize these formulas. You'll have those, and you'll also have your note packet. But you need to know like when to use each one and then what pieces to use, like what is N, what is R, and so on. Grand finale. This was on our worksheet and this is on the review, so I would know how to do this for the test. It says you want to have 10,000 after. That's your after amount. So that's actually the A in our formula from down here, because this is after and then this is our before money. and this is our rate, and this is our time, and so on. So the 10,000 is actually out front, and there was a problem like that on the worksheet. If you need to go back and look at it for that 7.2, go back and try it. It's the very last one. Find the amount of your initial deposit. So you're trying to find out the value of P. So I don't know that. If it pays, it says 2.75%. If you want to divide that by 100, you're going to get 0.0275 as your rate. And it's compounded quarterly. So I'm putting a 4 there because that's 4 times a year. And then that same n goes up here because it's here in my formula and again in the power. And then I'm supposed to multiply it by the time, and it says 5 years right up here. It says 5 years. So you're saying, okay, I want to have 10,000 at the end. How much do I have to start with? So here's the deal, you guys. These are all numbers. So do that part on your calculator, and then that will be a number that's getting multiplied by P. So type in that whole thing, and then you'll have 10,000 equals P times, I got like 1.14686, and then I'm going to divide that out. To both sides. This will just cancel, leaving me with my principal value. And I got a principal value of $8,719.45, which makes sense because if I'm gaining interest and at the end of the 5 years I want to have 10,000, I need to have started with something that's less than 10,000. So that all hopefully makes sense. So if there's a part you don't know how to do, go back and practice. If you are terrible at graphing domain range, go back and practice 7-1. The word problems, all of these word problems, even these guys up to here, 7-2. Even this is 7-2, just with the exception of the one that said continuously. And so then this section here is the only one that's really 7-3, except for this problem. So there's not a mystery of what your test is going to be like. So just use your resources. I'll make sure to put an answer key online that shows the graphs because the current one doesn't. I must have just spaced it out and didn't do it. So hopefully you feel better about it, and hopefully you ace the quiz. Bye, guys.